Welcome everyone, and thank you for joining. This webinar is co-hosted by the Massachusetts Ecosystem Climate Adaptation Network, or MassECAN, the University of Vermont, the University of Massachusetts Amherst, the Nature Conservancy, and the Northern Institute of Applied Climate Science, or NIACS. My name is Sam Myers, and I'm a forest adaptation specialist at the University of Vermont and the Northern Institute of Applied Climate Science, and I'll be moderating the webinar today. Before we get started with today's webinar, I just want to go over a few logistics. First, we are recording today's presentation. The recording will be shared with all registrants after the webinar. Also, during the webinar, you will not be able to unmute yourselves or come on camera, but please feel free to add your questions to the Q&A box during the webinar, and we'll have time to address these questions at the end of the presentation. Also, this webinar is eligible for one continuing forest education credit through the Society of American Foresters. If you'd like to earn credit for attending this webinar, please fill out the attendance form that's linked in the chat. In today's webinar, we will learn more about the new Reforestation Guide, Tree Planting to Enrich, Restore, and Adapt Northern Forests. This Reforestation Guide is a practical resource for foresters, landowners, and managers interested in using tree planting as a forest management tool. You can download the guide using the link in the chat, and I'll share that link again in a minute for those who joined late. Today, we're going to be hearing from two co-authors of the guide, Peter Clark and Tony D'Amato. Dr. P. Clark is a research associate faculty in the Rubenstein School for Environment and Natural Resources at the University of Vermont, as well as with the Northern Institute of Applied Climate Science. His research focuses on forest ecology and management with an emphasis on regeneration ecology. Dr. Tony D'Amato is a professor of silviculture and applied forest ecology and director of the forestry program and research forests at the University of Vermont. His research focuses on long-term forest dynamics, disturbance effects on ecosystem structure and function, and ecological and adaptive silviculture strategies for conferring adaptation potential within the context of global change and diverse values and objectives. This resource was also co-authored by Paul Catanzaro, professor and state extension forester at UMass Amherst. And with that, I'll pass it off to Tony and Pete.
Thanks, Sam. And it looks like there's a comment about the chat being disabled. And so the Q&A function, I think, is the way that folks will be able to interact. But please let us know if you need the links that are in the chat right now to be posted into that as well for folks to access that. Thanks, Sam, for the intro, and thanks for the wide interest and folks logging on today for this. I'm Tony D'Amato at University of Vermont. I'll be talking for a little bit just to kick things off, but really we'll hand over the reins to the person that's done the most thinking and the most work on this guide and topic, Pete Clark. But just to start things off, and Pete, if you want to advance the slide. If someone had asked me 20 years ago, like if you'd be giving a tree planting presentation in the year 2025, I think they were crazy. I think as many of us that work in forest management, particularly either in regions of the Northeast that do a lot of tree planting, like Minnesota, or maybe you got a degree at NC State or Oregon State, or somewhere where tree planting is the primary form of reforestation, you recognize there's a tremendous amount of knowledge already out there in terms of how do we actually do reforestation, plant trees across the landscape. But what really has motivated this guide is two things. One, the reasons we're planting has changed dramatically. And so a lot of our general knowledge around reforestation very much is for establishing fully stocked stands of timber producing species. And then the regions we're planting is also changing. And so you could have all the best knowledge in the world on how to plant, but you're trying to pull that off in Vermont or a state where there's just not that both institutional capacity as well as knowledge to pull off reforestation successfully. And so what we're hoping to do this morning, and certainly in more depth with the guide, is really think about both just best practices for being a good steward when it comes to planting trees, but also really weave those into these new reasons why we're planting, and that really often is requiring different practices in a different mindset than what may have been ascribed from our historic approach to just planting for timber production. So I'm going to go through just some of the broad motivations for planting that are a bit different than historic. And then Pete's going to take it from there and talk about what's in the guide and how that hopefully can be useful to you in your efforts. So if you want to go to the next slide, Pete. So we've been planting trees for a long time across the US, but really over the last 15 years, there's been a real increase in the amount of interest in planting trees. And one of the primary drivers, especially for large scale initiatives around planting trees, has been just the recognized value that trees play in climate mitigation and how that can actually enhance the mitigation potential of areas that either don't currently have trees or maybe are understocked for various reasons. And so the picture on the left of the US is from some work that Grant Domke did looking at just the acreages of understocked forest land in the US. And from that work, what they generally found is that if we were able to either via natural regeneration or tree planting, get those areas to a fully stocked condition, that would increase our carbon sequestration capacity by 20% per year. And so certainly a desirable outcome given where we're at today with carbon emissions. Tied to this have been some pretty significant either state level or global initiatives around planting either millions or billions or even sometimes trillions of trees, all of which are often using as a primary motivation for that work the goal of more trees out there sucking carbon out of the atmosphere and providing a lot of other benefits. Next slide, Pete. Tied to this impact of climate change and this desire to have more trees out there is we also are losing more trees than we ever have from novel dynamics. And so depending on where you're logging in from today, you're either thinking about emerald ash borer, spongy moth, beech leaf disease, Asian longhorn beetle, hemlock woolly adelgid, all of the above. And those have really resulted in some pretty significant rates of tree mortality over the last couple of decades. In particular, the map on the right is some work that Lucas Harris has been doing, just looking at mortality rates across this quadrant of the Northeast. And what he's generally finding is that mortality from things other than humans has really become the dominant form of disturbance across our region. And in particular, those states that are outlined in bold are ones in which over the last 6 years have seen a significant increase in mortality from insects and pathogens, well above what we're seeing from other causes from forest harvesting, clearing, et cetera. And so that loss of canopy trees is motivating a desire. Can we get other trees out there in the landscape to adapt to this impact? Next slide, Pete. Of course, a lot of the discussion around tree planting, particularly in a forested context, in the realm of adaptation, really gets at this challenge that we're facing in that trees can move, and we know they've moved historically in response to past climate change, but they unfortunately, don't have that extra horsepower to keep track with how fast climate's changing now. And so on the right, I just have like a liberal estimate of how fast trees moved to track climate after the last glaciation, 10th to 3/10 per mile per year. And if we look at the rate of climate change and projected shifts in climate for a lot of the region that this guide covers, we're talking about 4 to 6 miles per year. And so the ability for trees to naturally track that is limited. And so there's this motivation that should we be moving trees or enhancing the representation of trees that might be better adapted to the climate that's shifting into an area. Next slide, Pete. So as I mentioned, a lot of experience really on the attendance list for the webinar in our collective forestry communities on how do we plant trees. And again, the main knowledge base really is tied to, establishing fully stocked stands of timber producing species. And if we look at number of seedlings planted alone, that is the most common application of planting globally. And it will remain that just based on number of trees planted. But if we look at why people are planting and the frequency of what's motivating planting projects, this is the least common reason people are planting now. The reasons really are quite different, ranging from trying to sustain black and brown ash in the landscape, and so establishing nurseries and collecting seed and finding ways to keep that species as part of lifeways for future generations, trying to create redundancy, potentially in functions that might be lost, whether it's the deep shade that hemlock casts, the nuts that beech produces. Can we actually do things to sustain that into the future? And then, as I mentioned in the previous slide, as climate's changing, as the species that are currently present might become more maladapted, are there ways for us to augment natural regeneration through other species or other genotypes that might actually increase the adaptive capacity of that system into the future? Next slide, Pete. So the motivation for this guide really is our own trials and tribulations trying to plant trees in the Northeast U.S. And so, as I mentioned, there's a lot of experience, with tree planting in many parts of our country, and certainly even parts of the Northeast have an amazing capacity to do this. But 10 years ago, when we first started talking about planting trees in Vermont, New Hampshire, New York, and doing it at scales beyond, a few hundred trees, it became pretty clear that there were two major challenges. One, the way we were planting and why, like related to climate change adaptation, wasn't really the common approach to things. And so we often couldn't find the species or sources we needed. And importantly, this region really has been benefiting from great natural regeneration for a long time. And so most foresters and most folks interacting with the forest aren't thinking about tree planting in their day-to-day operations. And so there's a real knowledge gap in terms of how to do this well and ensure that the long-term outcomes are positive. And so what Pete's going to do is go through this guide and really, to be honest, his lived experience in pulling this off at larger scales to give you a sense for what this resource provides, as well as to go through some best practices. So Pete, take it away.
Thanks, Tony. That was a really nice introduction to the guide and really outlining some of our thinking. I'll talk for about 30 or 40 minutes, and Tony and I will be able to sit around after the call to answer some questions until around 11:15 Eastern, if we end up running over. But at this point, I'm going to really dive into the background of the guide, provide some high-level thinking into some of the details, really highlight the key topics that are introduced to the guide. Given the diverse experiences in this guide, we'll generally keep this high level, but certainly direct you to the guide or willing to ask questions and talk about the details as we conclude this talk. But I want to just set off by acknowledging the many reviewers and folks that contributed case studies. Their experiences and their backgrounds really lent a level of expertise to this guide that wouldn't be possible without them. So just wanted to lead off by acknowledging the many who lent their time and efforts and experiences to this. So this guide is, the aim of this guide is a resource for foresters, landowners, and natural resource managers to help make informed decisions when using tree planting to meet and sustain forest regeneration goals. We've written this with a Northeastern focus, the New England, New York, and Northern Lake states, but many of the lessons that we confer here are broadly applicable outside of this region. And while it's not an exhaustive text, it would be 500 pages if it were. It largely covers the key topics to better position the user to take their next steps in their key tree planting voyage. We also put quite a bit of emphasis on generating vetted resources that were helpful to help the user home in on key topics where our review is a bit more superficial. The way in which we frame planting is within this forest management toolbox, where tree planting is really one strategy within this toolbox for approaching and supporting healthy forest function. Many of the ways that we frame this is through a lens of ecological forestry. So as Tony mentioned, rather than being production focused, it's aimed at thinking about ecological functions and sustaining ecological services of forests. This guide largely emphasizes how tree planting can be used to restore species and ecosystems, adapt to climate change, or mitigate the harmful effects of greenhouse gases. So let's just look at the guide. This is some of the opening pages, the table of contents, and I'll just quickly step through and introduce you to some of the concepts that you would read. So by leading off, we largely talk about some of the introductory material, why plant trees in this era. Section 2 is a bit more meaty. It's titled Regenerating a Forest. Every Journey Has Its Own Map. And this goes into some of the opportunities and objectives for tree planting and the different approaches that folks might be considering. Section 3 really gets down to brass tacks. Considerations for tree planting. Here we outline 7 key steps for successful tree planting projects from planning through planting and monitoring. We have concluding material, and then I also wanted to direct your attention to a glossary of terms as well as a whole litany of resources that can be helpful to again, home in on key topics. And then one of the aspects that makes this guide really helpful is that we have grounding experiences through various case studies. So the reader and the user can see these case studies, which highlight a diversity of approaches of planting across different ecosystems, geography, and management contexts. So at this point, I'll dive into the guide, and we've talked about some of the introductory materials. So we'll jump into the second section titled Regenerating a Forest. And here I'll give kind of a high level of some of the opportunities and objectives for tree planting. The first is titled Enriching and Restoring Forest Composition, Structure, and Function. Tony talked about some of these, but this is planting to restore key ecosystems, key species, responding to disturbances. The second topic is forest-assisted migration for climate adaptation. We recognize that climate is shifting at a rapid pace, so how can we implement this? The third is afforestation of historically forested agricultural lands as opposed to, say, planting in prairies. How can we use these open lands and plant within them? And what are some of the challenges associated with this? We go into bottomland, wetland, and riparian area plantings and some of the challenges and opportunities associated with those systems. Carbon mitigation plantings to elevate biomass on the landscape. Working with tribal partners to plant for cultural keystone ecosystems and species and enhancing those ecosystems. Planting with wildlife habitat or food sources in mind. And lastly, recognizing that financial and economic incentives are the wheels that aspects that grease these wheels. And so highlighting some of the cost share programs and opportunities that landowners might be able to engage with. So what to expect in terms of how we frame this section. We first lead off with a topical review, so an explanation of the key concepts and terms, and then step into the considerations and best practices. What are the guiding principles, practical guidances, and links to key resources? And where available, we then pair these with case studies that then ground these ideas in how folks have used these practices on the ground to meet their own management goals. So let's just look at one of these opportunities for tree planting. And here we're looking at assisted migration for climate adaptation. So as Tony led off, climate is changing at a rate that exceeds the ability for trees to keep pace through natural dispersal. And so there's this idea of using tree planting to respond and match those climate goals. And so there's different types of assisted migration, assisted population migration, range expansion. I'll just briefly talk about those two. There's actually a third, but for brevity for today, we won't go into that. The first is assisted population migration. In this scenario, species that are currently found on site or located within their historical range are then sourced from seed sources from southern or lower elevations that are expected to be better adapted to future climatic conditions. And so there's different tools to be able to approach this. And one of the tools that we highlight are various seed lot selection tools. So you can identify a potential planting site, turn the knobs in terms of climate emission scenarios and the time frame in which you'd like those seeds or those trees to be adapted to, and it'll highlight a seed lot match, identifying potential areas where the climate might be matched to your future planting site. Assisted range expansion, this is the moving of species beyond their historical ranges into nearby or adjacent areas in anticipation of that increased habitat suitability. The nuance here is that this is where the species is expected to realistically establish via natural dispersal, but over long time scales, particularly without some sort of significant natural migration barrier, such as an ocean or large mountain. One of the tools that we highlight is the USDA Climate Change Tree Atlas. So here we're looking at, pardon me. Here we're looking at modeled future red oak habitat. This is a bit of a busy slide. And so the tree atlas generates some useful tools in terms of species habitat, and potential shifts in terms of those habitat ranges. The legend here, we're looking at habitat quality in HQ and colonization likelihood in CL. And just to quickly highlight how that tool can be used in the context of assisted migration, those areas that are desirable for natural migration are shaded in dark shade, so colonization likelihood might be high. But a user that's thinking about assisted migration would look at those lighter shaded areas where colonization likelihood is maybe low or medium, and that might be a target area for assisted migration. We then pair this with considerations and best practices. So a review of the literature in terms of generalized transfer distance. We recognize that species and certain different genetics can tolerate some degree of transfer distance. We generally recommend that approximately 200 miles or 2 to 3 degrees of latitudinal shift are generally considered safe. However, we often direct folks to this background image, this map, which is the eastern seed zone. So maybe recommending shifts of maybe 1 or 2 seed zones as a tool for the movement of seed and species. In addition to this, we also direct folks to the idea of a portfolio approach in terms of planting. And so I'm talking about this in the context of assisted migration, but it can be applied to various mixed species or genotype plantings. And so the portfolio approach is really a means of risk spreading by allocating different proportions of species, genotypes, or maybe even functional groups across your planting mixes. So here we have various ratios of those species that are adapted to maybe present day conditions, those that are adapted to maybe a moderate or warming scenario, and those that might be adapted to a higher climate warming scenario. So this might be one approach that a forester or landowner might use to employ assisted migration in operational context. And then we conclude with links to several helpful resources in terms of how do you make these decisions on the ground. Pairing this with a case study, Rick Morrill and Dan Kilborn from the Vermont Land Trust, Nature Conservancy, and the Northern Forest Conservation Service submitted a case study titled Assisted Migration and Cross-Boundary Management in the Northeast Kingdom. The project themes here are adaptive silviculture, assisted migration, again, the use of that portfolio approach of species and genotypes, and then also the interesting cross-boundary decision making across 2 ownerships and 2 parcels. The desired future conditions from this site in this case study are a diverse multi-age forest with climate resilient species to ensure a long-term healthy, stable, and forest with increased wildlife habitat. So the tactics used and highlighted in this guide, the use of canopy gaps to create diverse stand conditions, planting in slash to be able to protect from maybe deer browse, and then the planting of over 2,000 species from diverse species mixtures, those that are assisted population migration, so they're locally present, maybe using a more southerly seed source of white pine, black cherry, basswood, red oak, and red spruce, and the latter have multiple seed sources used. And those that are assisted range expansion, they're maybe found slightly south with expected increases in species ranges, black birch, bitternut hickory, a disease-resistant American chestnut, and white oak. And so these partners had many lessons learned that are submitted as part of this case study, lessons in terms of working with nurseries to be able to secure and find these diverse species and genotypes that are sometimes not available, engagement with cost share programs to offset costs, and then collaboration with neighboring parcels to offset their costs in terms of silviculture activities, as well as the risks associated with these projects. The second planting type I wanted to highlight is carbon mitigation planting. So as Tony led off, reforestation has been identified as a natural climate solution to mitigate against greenhouse gas emissions, with tools like the Reforestation Hub highlighting tremendous potential reforestation opportunity in terms of millions of tons of carbon sequestered a year across millions of acres and necessitating many billions of trees. And so while most plantings can have a positive carbon impact, the most impact can occur on understocked, degraded, or unforested lands. So I'm highlighting afforestation as a potential tool here. In terms of considerations and best practices, these projects should emphasize planting, again, in species mixtures with complementary traits. So those species and traits can occupy different amounts of space in the canopy, rather than, say, focusing on singular species or singular outcomes. We find that planting in mixtures can often result in what's called over-yielding in terms of biomass, or having higher levels of biomass or carbon, also enhance productivity, and also realizing other benefits outside of carbon, say wildlife habitat. We introduced a term called biomass packing, which is essentially the total amount of plant material found in an area, which can indicate how efficiently a site is using the available space, and point to Kelty's work in forest ecology and management, the role of species mixtures in plantation forestry. And we use this graphic to illustrate different planting scenarios. So in the top right, scenario A, this is a mixed species planting of complementary species with equal proportions of slow-growing shade-tolerant species paired with fast-growing shade-intolerant species that can maximize biomass packing or carbon. The second scenario, it's also a mixed species planting, including a more minor component of fast-growing species, ultimately to enhance overall carbon stock across the stand, but they're diversifying those forest canopy layers. And then the last example is a mixed species planting with a minor component of fast-growing species while providing food source or diverse habitat for wildlife, but also realizing some level of biomass or carbon benefits. And just to highlight some of our other case studies, Chris Zimmerman and Mandy St. Hilaire from Nature Conservancy submitted afforestation and floodplain forest restoration in the Neversink River in New York. It's a helpful guide. Julie Richburg from the Trustees of Reservation submitted managing transition forests in southern New England using genetic diversity, slash walls, and seed collection. Erica Rowland from the Greater Level Land Trust submitted functional reinforcement and enrichment of keystone species in western Maine, considering the loss of hemlock and planting of spruce. And then Paul Kroll and Mike Jones from the Stockbridge Muncie Community Reservation submitted underplanting to sustain black ash wetland functions at risk of being lost in light of emerald ash borer. We also put together this hypothetical ownership graphic, and this is a lot for one slide, so we'll take a minute to zoom in. But the goal here is to illustrate how planting can be used to achieve diverse objectives over different time steps across a single ownership. So let's just take a minute to zoom in across these different aspects of this graphic. So post-silvicultural treatment and planting in the first stand is a stand A. The description of this stand is a mature, even-age hardwood forest characterized by uniform tree sizes, a few species, and a continuous canopy cover. In terms of a treatment, harvesting of gaps was used to promote diversity and structural complexity, and planting of a diverse portfolio of species and genotypes from local that are representative of both local conditions, those are seedlings and trees that are green, as well as those that are adapted to intermediate or high levels of climate warming in yellow, orange, or red colored seedlings. Moving across the stand in stand B, the description is a keystone ecosystem characterized by conifers that are threatened by or dying due to an invasive pest. And the treatment is opportunistic underplanting of disease-tolerant conifers and potential functional replacement species in anticipation of a declining overstory. And then last illustration is a riparian zone and former agricultural area vulnerable to flooding and erosion. And the treatment used here is implementation of a cost share program to afforest lands by planting a diverse and biomass-rich mix of species of high ecological, wildlife, and timber value. And so as we spin this forward to stand maturity, here we're calling this 80 years post-silvicultural treatment and planting, you can see those starting conditions in the subset. The ultimate desired future conditions are a structurally and compositionally diverse and climate-adapted forest resilient to disturbances, capable of self-regeneration, and serving as a future seed source for future forests. Moving that forward to stand B, The desired conditions are a compositionally and genetically diverse conifer-dominated stand capable of maintaining a forest keystone ecosystem services. And then in the last stand, this has become a flood-resilient forest that provides new ecological values and a source of income for that landowner. And so taken together, this graphic aims to illustrate how a landowner might view planting across different stands and across a matrix of approaches. And so at this point, we'll transition and shift gears to the third section, considerations for tree planting, the 7 key steps to success. And what we'll do is just walk through and highlight some of the aspects across these 7 steps: setting goals, understanding the site, choosing the right seedlings, anticipating cost, design, logistics, and site prep, planting the right way at the right time, planning for maintenance, and then monitoring your outcomes and adapting. And so the first step, and we'll just keep this pretty quick, are setting goals and defining desired future conditions. So desired future conditions are clearly defined goals of how a forest ecosystem should look at, or function. And so articulating these objectives early on helps guide many key decisions, such as species selection, planting density, site preparation techniques, and it also ensures that all partners involved in the project share a common vision for what the future goals and the future forest can look like. Understanding the site is a critical part of selecting species and developing your planting plans. And it's foundational to making informed decision-making, having place-based management, and ensuring that your outcomes are durable and representative. Now, there's many aspects that can inform those site-level decisions in terms of natural communities, existing overstory type, but soils are one of these aspects that can dictate many of these planting decisions. And so just from a high level, soil type and associated soil properties such as texture, structure, pH, fertility, moisture, drainage are all important components to consider in terms of the tree planting project to match to the site preparation needs as well as the species or potential genotypes. And so understanding the land use history, proximity to water, other aspects can be important. One of the tools that we recommend folks get engaged with is NRCS Web Soil Survey. If you're not familiar with it, it allows for parcel mapping and soil mapping and an engagement and understanding those different soil types and associated soil properties to inform these decisions. We also wanted to highlight topography aspect and landscape characteristics as potentially informing some of your decisions. So, for example, a dry south-facing ridge may be more vulnerable to warming or droughty conditions. So considering this might be a possible site to transition to maybe a more future adapted forest in terms of species or genotypes. Relative to, say, maybe a north slope with a cold valley, that may serve as a refugia for change. So maybe maintaining those historic conditions through your planting efforts might be a consideration. Pairing planting decisions with silvicultural activities and appropriate light levels is also important. So under a closed canopy condition, most seedlings would succumb to lack of resources. And so matching that with the silvics of the species that you're considering. The exception here being underplanting, which is the establishment of species capable of persisting for a short period of time in anticipation of that overstory being removed when that and taking that space when the opportunity arises. So an example being maybe underplanting oak 1 or 2 years before harvest, or underplanting in a black ash stand before emerald ash borer takes over. Section 3 is choosing the right seedlings. This is a big part of the tree planting process. And the first recommendation is locating and connecting with tree nurseries early. So successful tree planting projects communicate with a nursery to source project appropriate seedlings. For custom orders and larger orders, these can oftentimes take 1, 2, 3, up to 5 years to be able to develop. And so having that communication early on to know if the inventory is available across nurseries is an important part of the step. And you can find nurseries through the National Reforestation and Restoration Directory, which is administered by the USDA Extension Service, ringer.net. If your project demands specific species or seed from a specific origin in terms of climate adaptation or local seed sources, you may need to contract a seed collector or collect your own seed. And one way to get involved and start this journey is to download the free available Woody Seed Plant Manual, which is a great resource. One of the long-standing conservation paradigms in planting is local is best, and so priority should be placed on native species that are local to your area, while simultaneously recognizing this balance that considering that's climate suitability for today and into the future. So maybe planting seed that originated in a warmer climate that is presently in a cooler environment, and then as those climatic conditions warm, that species and that seedling will become more adapted to that site. At a very high level. There are many tools that we've introduced already, but USDA, the Climate Change Tree Atlas, seed lot selection tools, Eastern seed zones, as well as regional floral guides can be useful guides in terms of making these decisions. Well, we talked a bit about selecting species. In many ways, focusing on selecting based on functional traits can be an important part of this decision-making process. So selecting species with different or complementary functional traits can be important to support resilient forest functions. And so folks are familiar with many of these traits in terms of shade tolerance, drought, water logging tolerance, leaf characteristics, seed sources, seed mass. One term that we introduce and talk a bit about is functional redundancy. And this is the presence of multiple species in a stand that may perform similar roles or functions, such that if one species is lost, there are others that can still maintain those key ecological functions. And so the example we have is the potential loss of beech and those carbohydrate and nutrient-rich beech nuts from beech leaf disease. And so could you plant potentially hickory or oak or other hard mass species to be able to potentially replace that seed and that potential wildlife food source, as an example. We also have a large table of 40 candidate species, and we recognize that there are plenty, but way more species in this region that could be planted. But we use this as a means of highlighting the potential traits that one might consider, the adaptability scores that can be generated to inform these decisions in terms of, is this species potentially climate adapted to my region, the soil requirements, the maximum seed transfer guidance generated from the literature, and some of the other key values in terms of cultural and economic values that a species may confer. And so you can look to this guide to look at and refer to this candidate list, and also add other species to this list that may be potentially candidate species in your planting project. In terms of choosing the right seedlings, the stock type is also an important factor in determining survival and performance. The seedling stock types are typically distinguished whether they are containerized or they are bare root, as well as by their size and their age. And there's a whole, you can go pretty deep on this topic, but just to keep it pretty high level, bare root seedlings are those that are grown outdoors in nursery beds and then lifted from those beds without the soil around their roots. This is highly cost effective, they're compact, they're typically harvested dormant, and therefore they must be handled very carefully to prevent drying and planting shock. So transportation, planting in the field, ensuring that they're planted correctly is really important with these bare root seedlings. Compared to containerized seedlings, which are grown in individual containers of varying sizes, and they're filled with some sort of soil or a growing medium, these can sometimes be more expensive and sometimes more cumbersome and heavier to transport. But the trade-off is that having that soil promotes root protection, reduces transplant shock, and can support high levels of survival and performance, particularly on really challenging sites. Stock types have different costs, applications, and considerations, and I recognize that this is a lot to see in one slide, and so we're not going to take too much time to get into this table, but we include a table that outlines generalized seedling size classes, the stock types, and considerations. And so for maybe a medium-sized seedling size class, this is a standard size for planting in many reforestation projects, and it balances costs, durability in terms of handling and survival relative to, say, maybe some extra large potted seedlings. They're oftentimes used in maybe more competitive environments or challenging sites, and they may have highest levels of survival, but they're oftentimes more costly to grow and to plant. Irrespective of the actual size of the seedling, as a pro tip, that root to shoot ratio, the amount of roots that can support the above ground portion of the seedling, is really the best measure of quality. We can go deeper on that, but we'll just leave that as a pretty high level pro tip for now. There's a number of other topics covered in this section, including other stock types, the use of direct seeding and aerial seeding, assessing seedling quality, getting sanitary and procuring sanitary seedlings, other seed sourcing considerations, as well as sourcing climate adapted seed sources. Section 4 highlights anticipating planting costs, design, logistics, and other site preparation techniques. And one of these aspects includes the density in which you're planting. And this can largely depend on the species or the traits of those species, the site type, the stock size, the expected levels of seedling survival, the presence of natural regeneration, or the overall planting objectives, whether it's to broadly reforest a larger area or to maybe enrich a small area for other purposes. And so we include different tables, including a seedling density table with spacing and the corresponding numbers of seedlings per acre. And then we also include a table which is generated from Vickers and others in 2009, which illustrates target stand replacing regeneration rates to achieve future canopy closure. And these are outlined across different forest types. So the natural regeneration rates of a bottomland site, elm, ash, cottonwood, might be lower than maybe a spruce fir site, and that may inform your planting densities. We also talk about planting arrangement. And so there's different approaches in terms of planting arrangement. One of the more common one is what we call uniform or gridded. This is common, this is convenient. Oftentimes there's concern that this sense of uniformity will confer that uniformity to the stand. And one of the ways that we see that we can get around this is, again, by planting in mixtures can offset that uniformity, mixtures of species and traits. Another approach is a randomized planting. This is opportunistic. It's efficient, and it's also helpful on more heterogeneous sites. It's more challenging to ensure that you're hitting those planting densities, though. And then clustered plantings. And this is a unique approach which can create unique habitats. It can create mosaics of more dense planted areas as well as more open areas, if that's your goal. And it can also serve to shade out competition within those smaller planting areas. And then, of course, a combination of these three. In terms of best practices, choosing the best microsite can be more important than maybe adhering to like a strict spacing. It's also important that planters be familiar with best practices in terms of seedling care, handling, transport, and storage. So prior to having the seedlings on hand, plan for cold chain and storage and transportation plans to ensure that seedlings are kept cool, safe, dormant, particularly for bare root seedlings. So there's different ways that we can use this in terms of accessing a cold storage or building cool containers or ensuring that your packages and boxes are kept closed so that moisture isn't released. Site preparation is an enormous topic, and it's a shame to relegate it to one slide, but for the sake of time, this is one process that can largely increase your planting success. And this involves clearing of existing vegetation that might be competitive to those planted seedlings, loosening of compacted soils, potentially even using herbicides to control vegetation, particularly invasive species, or in some areas conducting prescribed burns. Without this, highly competitive sites can overwhelm those planting seedlings and ultimately reduce planting success. Knowing how to plant in the right way at the right time is also an important balancing act. And one of the most simple tools is learning how to plant correctly. I can't tell you the number of times we walked through different planting sites and found pictures, images like this one in the middle of this dead, poorly planted oak with much of the root mass sticking out of the ground. So ensuring that volunteers, contract planters, yourself are planting at the correct depth and in the correct way is an important part of this, of learning how to plant. It's the last point from moving that seedling from the nursery into the ground. And we include step-by-step guides for planting in the correct way, in the correct depth, using different tools. This graphic is, again, too much to show in one slide, but I just wanted to highlight that we've generated a reforestation timeline, which can be used as a project management tool. And one of the main takeaways from this timeline, this tool, is that planting is not a one-time event. It's a process that can take years, but this project management tool can help facilitate some of those steps. So let's just zoom into a few of these aspects. Up to 36 months prior to planting, there's different processes in terms of scoping and developing your desired future conditions, understanding the site, contracting with nurseries, particularly for large orders, your silvicultural treatments, developing planting plans, and hiring maybe planting crews. And one of the ways we present this material is in terms of the typical timing, the steps and key decisions, and the notes and potential pitfalls to avoid. There's the planting window, which typically involves a few days or weeks where you're inspecting seedlings, you're briefing your planting crews to ensure that spacing or that there is a cutoff if there are harsh conditions in terms of windy or drying conditions, which can be detrimental to seedlings. And then lastly, we conclude with the following 36 months post-planting with different post-planting activities in terms of immediate aftercare, monitoring, competition release, and other aspects. And so switching gears to the post-planting aspect of the guide, there are a number of activities that can generate the greatest chance of your project succeeding and your seedling survival. And active and routine and regular maintenance is really one of those ways to do that. Some of the key maintenance activities include browse protection, controlling competing vegetation, potentially replacement plantings of those seedlings that may have that have had seedling shock and have died out, potentially controlling and monitoring for pests and diseases, and in some instances, which is generally not the case in more remote settings, using irrigation. And so we include a table of expected first-year mortality relative to seedling planting shock, transplant shock, moving from the nursery bed to the forest condition. And we have conditions, whether they're ideal, all the way down to the worst case scenarios and what might be some of the culprits for leading to planting success or unfortunate failure. The negative impacts of wildlife browsing seedlings is one of the biggest barriers for establishing a new forest, and this can't be understated. This the impacts of deer, folks are very familiar with, maybe moose, snowshoe hare, small mammals like voles, can damage the tree leaders and growth form, generate odd growth forms like this truffula tree, resulting in dead seedlings from repeated browse or girdling. And so there are various management options that are available to mitigate the impacts of browse and predation. Some examples include planting in slash, which can be challenging for the planter, but also challenging for large mammals to be able to navigate through, at least in the near term. Tools like bud capping, stapling a piece of paper over the top, particularly of conifers. Various tree tubes are available. Mesh tree tubes are a useful option. I'm a big fan of hard plastic tree tubes, but they tend to be a bit more expensive, but they're a great tool. Other folks have used galvanized wire mesh and stakes around individual plantings that require a little bit of work to fabricate. Folks have been interested in the use of slash walls. This is the use of pulpwood and canopy tops to surround planted areas to make it challenging and more difficult for large mammals to be able to navigate and actually enter the harvested and planted area. The use of repellents, which requires repeated entries, deer fencing, large 8-10 foot fences, which is expensive but highly effective and can also support natural regeneration, as well as those planted seedlings. And then also creating large enough harvested areas that can allow for higher levels of vegetation to be able to regenerate, which can potentially overwhelm the browsers with a food source. Native vegetation can also outcompete plantings and may or will need to be controlled. And there's different tools to use this. We oftentimes use brush saws, but also herbicides and select applications of different mowing techniques can be available, particularly in more gridded plantings. And so while vegetation can have some benefits in that they can serve as trainer trees so that seedlings grow tall and straight, they can potentially buffer against extreme conditions, they can serve as an alternate food source for browsers. But in general, particularly in this region, controlling vegetation is important, particularly for the first 2 to 3 years to ensure that your seedlings are able to establish and become free to grow. And then the last point I wanted to highlight is monitoring outcomes and adapting. Monitoring is an important step to assess if post-planting interventions are needed, whether planting goals and desired future conditions are met, and to identify early signs of stress, failure, or even hopefully success. And so we include a table which highlights various monitoring foci, what to monitor and potentially how to monitor. These are key components that you can pick and choose from, but really just highlighting the aspects of monitoring to ensure that your projects are potentially successful and how to intervene as needed. Balancing monitor obviously is a balancing act between your capacity to be able to get out there, but monitoring is key, particularly for maybe more novel plantings like assisted migration or those that might be pushing the envelope a little bit. And then before I conclude, I just want to point out again, this is not an exhaustive resource. It's hopefully sets folks off on their journeys of planting, but we want to highlight that there are a whole slew of resources in terms of glossary of terms, resources, decision support tools, and supporting literature in this guide that will hopefully be useful to hone in on key aspects. And so with that, I'll pass it over to Tony to wrap things up.
Thanks, Pete. Yeah, I'll give you your voice a break for a few minutes before you answer questions. But yeah, just a couple of final comments, and I have been answering questions throughout this. So a lot of great questions already coming in. But I think just one piece of this is that, you know, as we're in a period of time where there's this real urgency to get trees planted, whether it's because there's a certain initiative that's paying for 3 years to do this, or you just feel like you're dealing with a situation where trees need to get in the ground today. It's important to recognize that really the success of that is going to be measured in decades, if not centuries. And so really being thoughtful about this and really reflecting on best practices, both for success, but also best practices as it relates to things like what's locally adapted or likely future adapted, or what's going to provide the most range of ecological, cultural, social, economic benefits. And I think a great example we all walk past many times a year, depending on where you work, are those civilian conservation corps plantations that are across our landscape, and that many of us say, why did they do this? And the reason they did was because those were the trees available. They had to do things at scale, and those species got put out at a pretty large pace and over a large area that now we are trying to restore to something else. And so really thinking about the long-term outcomes and what that might mean. An unfortunate bucket of cold water on that first bullet point is that those of us that are kind of in the thick of trying to do this at large scales and do it right, that is, you know, diversity of species, diversity of genotypes, you know, as well as thinking about different ecological functions, already know that there's a huge issue right now with seedling availability, both in terms of number of trees, but more importantly, a diversity of species, a diversity of genotypes, and a diversity of stock types. And so we're really lucky to have amazing state nurseries in our region, as well as amazing, you know, local growers, and they're doing all they can to kind of meet this need. But the more you can connect with those growers, the more you can work with foresters and others to kind of really be specific about what you need. That certainly signals a market demand for more than what is reliably being produced at these nurseries, and really will allow us to have the range of options so that we don't repeat the Scots pine, red pine, Norway spruce, and everything else we look at today, because that was available. And so if you know even more important people like policymakers, like this is a huge issue that we need funding going towards, if we really want to be doing reforestation in ways that are thoughtful and looking to the future. Next slide, Pete. So as Pete mentioned, lots of folks that formally gave guidance. Some of these folks also are kind of an informal support network on what it's like to plant trees in the Northeast in the current context that we're working in. But I just want to acknowledge the diverse funding sources and perspectives that went into this guide, and certainly appreciate all the work that went into this guide. Next slide. So there's been some questions already. Can I get a hard copy? So Paul Catanzaro is not here today on the webinar, but Guthrie Diamond, who works with Paul, is willing to mail you copies of the guide. So certainly send Guthrie an email if you want a hard copy. And then again, there are various links to PDFs out there. This one works to be able to get a copy of the guide, which is dense and has a lot of information in it, and gets at many of the questions I'm seeing kind of pop up throughout the webinar. So we're happy to answer questions live now, but appreciate people's attention and certainly feedback.
Thank you so much, Pete and Tony. That was a great presentation and awesome resource to share. We have time for a few questions. Pete and Tony said that they would be willing to stay on after if people are up for staying after the hour, and we'll also try to share out the kind of written Q&A that's been answered with participants after the fact if you do have to hop off. So I'll pick a question here, starting a little bit broad from Christopher Riley. Can you speak to some of the considerations that you believe are most in need of additional attention, training, improvement, et cetera, for successful tree planting in the Northeast?
Yeah, there's a lot of layers to that. I think you know, even when we think of, I think it's always going to come down to what we're able to put in the ground, and so I think we have some great knowledge in our region, either like regionally, folks like Kerry Pike, then like locally, folks like Billy Cornelius at a state, folks at nurseries, and then more broadly thinking about reforestation that understand what it takes to source the right seed and kind of turn that into a seedling. And so there's real need, I think, to grow that capacity, that workforce around like seed collection, seedling production, and then kind of that workforce pipeline of actually doing reforestation. There's a question in the chat about these reforestation contractors that do work a little bit in our region, work a lot in the Lake States, and definitely work a lot in the West and Southeast, where like a big part of the forestry workforce includes like folks that do reforestation that follow the practices that Pete's been enumerating here that again, sadly, just don't happen in our region because we just don't do this very, very regularly. And so I think there's a need for that workforce pipeline, that folks that are actually running businesses that provide those services. And then for the foresters, we are, just speaking for myself, silviculture is fun in our region because we can do it with natural regen, and do it free in that respect. So few of us have a deep knowledge of like successfully pulling off a reforestation project, unless you've worked elsewhere, in the country where that's part of what you do, or the few foresters that do that at scale in our region. And so I think there is a continuing education need there as well, that for those from elsewhere might say, we learned this like when we're undergrads. That's just, you're just not part of our like management culture. And so I think there's a continuing ed need there as well. So all layers to it. And I guess the last layer is also at those that are actually funding or saying we want these things, like to know like what it takes for that to be done right, so that they're sending the money to the right places and supporting the right folks out there. And I would say Nature Conservancy has been, and New York State both have been doing some great work in that realm, like trying to grow that capacity to do things well. But it takes time.
Yeah, thanks. That was a really good answer. Also staying a little bit broad here, Zach Adams was asking, do you expect any regulatory pushback against assisted migration species that are not currently detected in a state? Example being permitting for restoration projects that requires revegetation of species native to, the Massachusetts county where the project occurs. So any experience dealing with that, obviously it probably depends state to state and jurisdiction that you're working in.
Yeah, there are a few examples, and historically, some states, lesser in the northeastern region, would have guidance in terms of native seed lot collection or species. Um, it's really on a case by case basis, as states have guidance, have started to generate guidance, and some states have made a climate forester that they've hired on to help inform some of their decisions in terms of how forests can be used for management, and again, tree planting or system migration being just one of those tools. Um, Assisted migration can take many forms, and the movement of genotypes is not historically actually not an unusual part of tree planting. I think in many ways that's historically been done. Maybe haphazard is maybe a little bit too aggressive of a term, but unintentional. Just securing seed sources based on of a species that maybe is already in your stand, but that seed source is from a totally different region because that's just where that seed was collected, and that's where that capacity is. And so maybe to a lesser extent with the genetics and the seed sourcing, as we get into the movement of species, there's such rich species diversity, and many species that are already found in the region. It's on a small case by case basis in terms of species. We generally, I didn't talk a ton about this, but there's the extreme end of assisted migration is the movement of species that would never realistically get there. And I think that's where, understandably, a pushback would arise. We have a long history, as Tony mentioned, with CCC and other historic plantings of planting Scotch pine and Norway spruce and species that are would never historically come to this region because there's large boundaries and borders and oceans in the way. But in the context of assisted migration, being intentional and being aware of the presence in those ranges of those species is an important part of making those decisions. This is a rambling way of giving a broader framing of assisted migration. In terms of pushback, there are states that are working to grapple around these decisions and develop policies around this, but it's still in early stages. And so we hope that guides like this, as well as the peer-reviewed research, can help inform the risks as well as the benefits. And those risks also include the risks of inaction. Tony, you want to expand on that at all?
Yeah, I mean, I think just trying to, I guess, weigh the risk. I mean, obviously, there's going to be regulatory things that'll prevent, irrespective of whether the science suggests you should do it or not. Like if a state thinks it shouldn't be done, then you can't do it. But I think, yeah, just trying to weigh the risk versus the goals and values you're trying to sustain there on the site. And so if that species is the only option to keep something going there that may be lost, that might lower your risk threshold a little bit than relative to like including a long distance transfer or maybe like a potentially invasive like a black locust or something in the mix, depending on where you are, how you view that, just to have a diverse portfolio. So I think there's also just that lens through what you're trying to achieve that's critical. But there is guidance out there from some states, and then also again, great resources, through work that Kerry Pike others have done around reforestation. That can be good things to look at too if you don't have a specific guidance to your region or state.
Thanks. That was really helpful. Hopefully to that person as well. There were a couple questions that came in about deer herbivory and protection. For someone wondering what a truffle tree is, so you can work that in here. But what guidance can you suggest for deciding whether to use tree shelters to prevent deer browse? And if you have any kind of research on success of tubing natural regeneration following a harvest.
Yeah, it's a cost, right? To do that. There's little, I mean, you can leave tops and, but then the planting is really fun. That's one challenge, that recommendation we often use for protecting natural regen. Um, yeah, it makes it a pretty rough planting site because we've certainly planted into those situations. Um, and but so it's a bit of cost, it's a bit of scale, and then also certainly the species you're trying to protect. And so if it's large scale, it gets harder to do like tree level protection, so things like tubes and tree shelters, bud capping, those that are familiar with that from the Lake States region, that's often used for conifers. That's pretty cheap. It's a piece of paper being stapled to the terminal of a conifer. So that one is pretty scalable, using repellents like plant skid, um, costs money, but pretty scalable. And then deer fences that, and slash walls tend to be particular where folks might go if it's a larger reforestation effort, that can't afford to put a tube on every tree. And then when you do tube, like there's some comments in here. I mean, they're not perfect. And we also, yeah, curse them. When we're taking, they can be challenging to get off. They can, affect the growth, they challenging to get on, affect the growth of the trees a little bit early on. But it's, in some cases, the only way that you're going to guarantee success, including things like, those of us that work in spruce fir countries, snowshoe hare can be pretty wicked on planted spruce. And so, if you're not protecting them, it can be in other species in those forests, it can be an issue. So I think, weighing it really is around like, is this going to at least guarantee that tree survives, through that critical bottleneck period or not? And then what resources do you have available to pay for that? And if it's limited, you might have to, either just rely hopefully on slash or other approaches to protect the trees. But if you do have the resources, things like repellents and, as well as, individual tree protection can be helpful. And then with natural regen, absolutely, you can do the same thing. It's a little bit harder, depending on the growth form, so sometimes like caging is a little bit more effective. Again, costs money to do that, but it's a little bit harder to get a tube, onto a naturally developing tree, just given it's, you're easier when they're small, kind of hard to throw it on when they get to be, you know, breast height and height. So, but definitely that's used a ton, to protect individual trees that are natural as well.
Yeah, and we try to provide a bunch of examples in the guide of how folks have approached this challenge because it is a wicked challenge, for reforestation in the region. In one case study, they planted 15,000 seedlings, and while individual tree tubing was available at a few bucks a tube and a stake, and you factor in the costs in terms of labor of installing and then regular maintenance annually to ensure that those tubes aren't tipped over or causing deformed growth forms. It's actually more effective for this larger scale planting to actually use a larger fence that surrounded a nearly 50-acre area, which is pretty substantial, a huge cost. But the co-benefit was that it also supported natural regeneration to regenerate. And so that project ultimately was pretty successful, but a large cost, and that was available for that project and that landowner. But yeah, we try to provide a suite of options, and Tony did a great job of scaling them across cost and feasibility. But yeah, it's usually a few $100 an acre to think about tree tubing or something like that. So just factoring that in relative to the maintenance, and it can be one of the biggest filters in terms of the success of your planting. You can put in a ton of effort to sourcing the right seedling and everything else, but if they're not protected, particularly in areas with high deer pressure or browse pressure, it can pretty quickly, a planting can be wiped out even in just overnight post planting. These seedlings are pretty tasty. So
Thanks for that. I think we have time for one or two more questions here. We had one question come in about monitoring post-planting with the improvements in quality of remote sense data and potential applications of AI. Do you see opportunities to leverage remote sensing for post-planting monitoring activities?
Yeah, both ends of it, right? So especially those that are, if you think of like we're kind of lucky, I guess. So we're groaning about all the things we're challenged with, but if you're trying to reforest a post burn site in the Southwest U.S. or other areas, um, the ability to even like create like a fine detailed microsite map of that site in terms of, like they call it, kind of micrositing out there to really get those trees into the best planting sites possible that have success. And so similarly, yeah, I mean, as we continue to advance the ability to use drone-based imagery, whether it be LiDAR or just like raw imagery, like even being able to scan and kind of understand like what's out there pre-harvest, post-harvest, pre-planting to help with that layout can be huge. And then similarly, being able to kind of monitor, it's a little bit easier in plantations, I'll be honest. It's hard, like our forests, as we all appreciate, whether it's what we want to come back or not, like something comes back besides what we plant. So those trees can get pretty masked pretty fast. And so you would want to be able to like have a really good like initial year assessment. So before the veg is grown in, to know where those trees are, and that would allow you to kind of repeatedly sample those spots. But absolutely, no, it'll be a huge, it already is become a huge game changer for like how we monitor and assess forests over time. But I would argue it would be from pre to post to long-term monitoring, all the above.
Awesome. And last question here before we kind of close out. Thanks for folks who are able to stay on. And hopefully we'll be able to answer some of the questions in written and share those out with participants after as well. But let's try this question in the context of assisted migration and climate change. Are there recommendations for planting native species whose seed origin is from a warmer plant hardiness zone? How far do you stretch the plant hardiness spectrum between your site and the seed source?
Yeah, we talk about that in some detail in the guide, as well as point to other resources that really take a deeper dive on this topic. Plant hardiness zones are a really great tool that folks are familiar with. We also point to the Eastern Seed Zones map, which is a combination of ecoregions as well as plant hardiness zones. And so this can be a really useful tool for identifying seed zones for maybe a native collection, as well as if the goals are to push the envelope in terms of climate adaptation. And so Eastern Seed Zones allows for turning of the dials to look at different climate emission scenarios to identify how those zones might shift relative to warming trends. There's different guidance that we provide within the tool. There's linear guidance, so there's empirical evidence that many species can tolerate up to 200 to 300 miles of shift. But in terms of seed zones, we'll oftentimes recommend maybe one or two jumps in terms of a seed zone from the Eastern Seed Zone map. So that can be one practical tool like benchmark to be able to make those decisions in terms of where you might want to source your seeds. But I encourage you to also look at the seed lot selection tool, which models different seed collections zones relative to climate, and develop an understanding of how under different warming scenarios, under low emissions, medium or high, how the seed collection zones might shift. In addition to that, it also just emphasize the concept of the portfolio approach. So really trying to diversify your the structure and mixtures of your plantings. That could be in terms of species, but also in terms of genotypes and seed sources. And so if your goals are to plant white pine on your site, maybe plant some proportion that are currently adapted, native to the region, native genotype, native seed, maybe some that are from one seed zone south, that are maybe adapted to a slightly more moderate warming scenario, and then maybe push the envelope a little bit and plant some smaller proportion of those that are adapted to maybe a high extreme climate warming scenario. And this way, your proportions of seed and future seed sources, that risk is spread across multiple genotypes, and your likelihood of sustaining that white pine or that forest function is greater in the context of shifting seed lots.
Awesome. Thanks so much. We're gonna close out. Thank you all again for joining us today, and huge thank you to our speakers, Pete and Tony, for the presentation on this great new reforestation guide. Really exciting and great to have the engagement of everyone here today asking questions. As a reminder, a link to the recording from today will be emailed to all of the registrants, and we'll also try to include the answered kind of Q&A that we went through today. Also, as a reminder, if you're interested in earning continuing forestry education credits from the Society of American Foresters, you can fill out that form linked in the chat. They'll also be included in the follow-up email. Thank you. Thank you, everyone.
Thanks, everyone.
Thanks, everyone.